What do I do with the handout that is called Representing Particle Level Changes in the System? It's kind of confusing. What does that mean? I am confused by these words. Here is what the words mean, and we'll put them together and see what it is you're supposed to do on this handout. Representing the way that we show something in our model. We represent it, we show it. The way that we draw it, particle level, particles. The smallest particles that make up a system are often the molecules and atoms. That's what we're talking about, that scale, that very microscopic scale of molecules and atoms, or little groups of molecules and atoms that work together. And are the particles that are too small to see with just our eyes. They are microscopic. The phase changes. So we had particle level and we had representing, now we have changes. Changes are the phase changes, like from solid to liquid to gas. The temperature changes or the transfer of kinetic energy. The wind, clouds, and precipitation, how when they change, what's going on at that molecule level, at that particle level, that's microscopic scale. And a system is a group of parts that work together. In this case, the system is all the weather conditions in a place. So the hailstorm is a system. Representing particle level changes in the system therefore means we are going to draw or show what happens to the molecules and atoms in the air and water when a hailstorm is created or made. We need to include the energy in the particles and how the energy is transferred from where there's high energy to where there is low energy. So we need to start thinking about that other handout where we model the weather conditions before, during, and after the hailstorm. Students drew that in many ways. In this particle level model, we're looking at the middle frame. So in this case, this person had drawn a nice day, blue sky, a tree. In the middle frame, they show the dark clouds, they show rain, and they show hail, and the precipitation with two different slightly colored dots and lines. They show the tree bending over, so the tree in the middle frame shows how hard the wind is blowing. Now, that's the frame we're going to look at, that middle frame. That's what you want to represent on that particle level model. This person did a different way to draw their initial model. They kind of drew out the separate conditions. And again, they showed that it was hailing and raining from the clouds and very windy at the ground level. So those are the areas we want to show. Um, One person mentioned that it would be much colder after the hailstorm. And they mentioned the changes in clouds and humidity. Again, this is the middle frame is the one you wanted to show on this particle level representation. We see a lot of stuff going on there. We see clouds and wind. We see wind blowing, hail coming down, uh, some rain. So they show the wind in the middle frame. Why do we see a rainbow in the sky after it rains? It's another question. And on this one, this person talks about how the hail being formed inside the clouds. They point out there has to be water vapor in the air, and humidity is another word for the water vapor in the air. So that's something we could show on our particle level representation, right? Show clouds, show the changes from water vapor to ice to big chunks of ice that are hail. So, what are the conditions that people think will happen during hailstorms? We've got wind and clouds and sunshine, and clouds and sunshine. Of course, the sun doesn't actually go away. What's the sun do? Where does the energy come from when we have changes in energy? Got to have some water vapor or water vapor humidity in the air. There have to be temperature changes. The temperature somewhere has to be cold enough to freeze the water vapor into ice chunks. And we know liquid water freezes at 0 degrees Celsius. Is that cold enough to make hail? Does it have to be much colder than that? How can we show what's happening in the storm at the particle level? In the unit on thermal energy, we looked at the fancy cup. We use dots to show molecules or atoms, or the smallest particles, and we use lines behind the dots to show how much energy the particles had. So here's one way to show the relative amount of kinetic energy in the molecules or atoms. So when I'm drawing my particle level model, if I want to show molecules with high energy, I could draw a dot with three curved lines behind it. And that same substance with medium energy, I might draw a dot with to show one molecule with a medium amount of energy. And if it had low energy, like say in a solid or in a chunk of hail, which is solid water, then I might draw a dot with just one little line. So the number of lines would indicate how much relative kinetic energy it has. How would I show the difference between solids, liquids, and gases at the particle level? Well, the particles in a gas have so much energy they're spread apart and move all over. So in a gas, I might show it like this, with the molecules just floating around in the air. They spread apart. There's no particular shape or size. In a liquid, the particles in a liquid can move around and take the shape of anything the liquid is in. And the particles will stay together mostly. So a raindrop stays together because it's liquid. It has a medium amount of energy in the molecules. And I might represent it that way. And the solid, the particles in the solid are arranged in a grid and they're locked in place. So I might draw my solids like that. So I have the three different phases of water that could be present in the atmosphere or on the surface of the ground or anywhere else. We've got gas drawn like that. We've got liquid drawn with the molecules together, but no particular order. And we've got them as a solid, as ice in this case. So how do I complete that handout called Representing Particle Level Changes in the System? Okay, so there's three circles that are for zoom in microscopic views or particle level views of what is happening to the water molecules and the energy in the storm at three different places. It says to pick any three places, put the letters A, B, and C in there. I would recommend we do one like A could be high in the clouds, B could be in the air around the bottom of the clouds, and C might be near the ground or on the ground. So your teacher will have you do this on paper or on canvas. You'll draw what might be happening at the molecule or particle level to make clouds, rain, and hail, and showing those changes in that middle frame of our initial model of how we went from water that had evaporated and it made a cloud, and maybe it made ice. Um, People talked about how it got bigger and bigger until it got heavy enough to fall down. Gravity pulled it down. They talked about that. So that might be something showing like near the ground or up high. And that's what this is about.